He's actually our UC Cooperative Extension Advisor, San Mateo, San Francisco, Alameda, Contra Costa, Santa Clara, and with a focus on urban forestry and arboriculture. You think that's enough area he covers? I read it in the Chronicle the other day where there's something like 67,000 public trees in San Francisco, and that's just San Francisco. So he's got a lot of area to be in charge of. He's taught at Portland State University and served as a California Science and Tech Policy Fellow at the state capitol. He's very involved in applied research and environmental management, especially as it applies to watersheds and grasslands, ecology and sustainable management of urban trees and water. And I want you to know he really likes broccolini. Okay, so give a warm welcome to Dr. Igor Lacan.
Would you prefer me to keep my mask on?
No.
I can, no problem. Good morning, everyone.
Good morning.
I presume the last row can still hear me. Okay, good. So, thank you for coming. We're going to talk about climate change and urban trees. And I want to thank you, before we start, for being master gardeners. We'll eventually get to the slides, but we can get started without them. The thing that I wanted to start with was this idea of the information that's out there, gardening information. And it's sort of a spectrum. And I'm not talking about from false to more false, but I'm talking just the way the information is presented. On one hand, we have story time. And everybody loves story time and myths, right? And just kind of that's what we humans do. If you want to offend somebody, go challenge their stories and their myths. It's a very, very good way to offend people. But it's also a very good way to motivate people or get them interested in something, right? You tell them a story. So, story of pollinators. How many people don't like the story of pollinators? Come on. Everybody likes the story of compost, right? It's so exciting, the biology, the soil, right? And the story of climate change, sure. It can be very inspiring, and it's also usually completely useless as far as taking action, right? You feel very inspired and you go home and the next day you're not sure what to do. On the other end of the spectrum are listicles. And if you don't know what a listicle is, it's sort of a short article in form of a list. 6 great plants for your garden, 3 evil insects that you should be on the lookout for, 6 things to do today. And those are specific, right? They give you things to do without context. And so they're frequently totally wrong because the list that may make sense in Livermore doesn't make any sense in Alameda. So what is in between? Well, you are in between. You are that small force that joins up with home gardeners to find out and to communicate to them locally relevant, specific, science-based information that helps them solve their problems, so not my interest or my hobby, but their problem, helps them improve their garden and helps them do that sustainably. So, thank you. And the problem with that, of course, is that's hard work, right? So, story time's great because it's fun. Listicles are great because they're short. And the thing in the middle is hard work. So, thank you all for doing the hard work. And there's Irene doing the hard work. So, thank you, Irene. So, we're going to talk about an approach that you're going to take to help figure out the best trees for the world climate. And that approach is substituting space for time. So I'm not going to give you a list, and I'm not going to give you story time. We're going to try to be in that middle of where we get the information that's specific enough and useful enough to help people. And so this is sort of the outline, but we can skip that and go on. This is sort of where we're headed. By the way, we're really talking about adaptation to climate change. This is not a climate change lecture. I'm happy to give you that if you want. That is more of a story time lecture. And eventually we would get to the climate change policy and we would talk about the 3 legs of a climate change policy stool, rickety as it is, which is abatement, mitigation, adaptation. And really today we're talking about adaptation. How do we live in a warmer climate? So we're not talking about what we're doing to prevent it or try to make it less bad. We're really talking about how do we ensure that we have plants that are still going to survive. I just want to point out that those two other legs of the stool come before. It's like reduce, reuse, recycle. The same way with climate change, it's abatement, mitigation, adaptation. So you don't get to skip. But again, we're not talking about the policy today. We're really talking about this kind of, all right, we need to help somebody do better with their plants. What are we going to do? And these are some of the things we're going to talk about. We're going to talk about understanding the weather, understanding the warming, and understanding some of the extreme events, and then saying, okay, well, these plants survived extreme events. Maybe that's something to consider for the future. Just a reminder, greenhouse effect existed before humans ever set their filthy foot on scene. Atmospheric greenhouse effect is something they teach in meteorology classes, typically in the first few weeks, where they ask you to calculate the average temperature of the Earth based on its distance from the sun. And they give you a nice short formula, and you plug in the numbers and you get the wrong answer. You get the answer of 0 Fahrenheit. That's the average temperature of the Earth based on its distance from the sun and the energy Earth receives from the sun. So then everybody has a moment where like, whoa, okay, this must be one of those didactic things. The professor's trying to teach us something. And what the professor is trying to point out is that there is another mechanism that heats the Earth, and that's the atmospheric greenhouse. And in very, very brief, would you be able to describe the atmospheric greenhouse effect to a 5th grader? Okay, so we know that the Earth has an atmosphere, and that atmosphere absorbs the energy differently depending on the wavelength of that energy. So if you look up today, you see the light coming right through at hitting you. So clearly that light did not get absorbed by the atmosphere, right? So that light and all that energy, and by light I mean the spectrum of energy that's in the Earth, hits the ground. It also hits the atmosphere. This gets very complicated very quickly. We're sticking to the 5th grade explanation. It hits the ground, warms the ground, and then the energy has to leave. This is the part most people kind of have trouble with, but if the energy didn't leave, then we would have already turned into a flaming ball of fire, right? So exactly the same amount of energy that hit the Earth has to leave. And it's leaving, but it's leaving at a much longer wavelength. You don't see the ground glowing, right? Right? You can measure the temperature, you know there's heat rising up from the ground, but it's a different wavelength, which we can't see. Some of that energy that's leaving gets absorbed by the atmosphere and warms the atmosphere, and then eventually leaves from the top of the atmosphere. That is the atmospheric greenhouse effect. It has nothing to do with humans, but that is the reason why we have a nice blue planet rather than a frozen white one. And you can compare this to our neighboring planets. Mars doesn't really have an atmosphere that absorbs outgoing radiation, and it is a frozen wasteland. Venus has a very thick atmosphere that absorbs most of that heat that hit Venus, and Venus is a hellish, superheated, practically ball of flame. And it really, the difference is in the atmosphere. Okay? Turns out there are some constituents of the atmosphere, there are some gases that they're mostly responsible for this absorption of the outgoing energy. And those gases are primarily water vapor and carbon dioxide. And so this was happening for millions of years before any humans appeared. And for, a couple of tens of thousands of years, this was all cool even with the humans on sea. Until about the late 18th century, when humans discovered they could burn fossil fuels, which is carbon that was once in the atmosphere, but then turned into plants and then turned into coal, oil, and natural gas, and hasn't been in the atmosphere for about 300 million years. But humans decided this had a lot of energy in it, and what could go wrong, right? There's no downsides to burning it, except people immediately realized what was going to happen is that carbon that didn't used to be in the atmosphere is now going to go into the atmosphere, which is exactly what happened. That thing, that red line going way up, is the actual measurement of the carbon dioxide level in the atmosphere. And shockingly, when you increase the concentration of a gas that absorbs the outgoing energy, you absorb more outgoing energy. And the Earth is now resetting to a slightly warmer temperature. That is global warming. Global heating, climate crisis, call it what you want. The detailed physics gets very complicated, but the basic idea is exactly as I described it. This is your 5th grade level understanding of global warming. Okay? When you look at where that fossil carbon is used, it's mostly used, or let me rephrase. When you look at where this additional set of carbon dioxide comes from, it comes mostly from energy production. Some of it comes from land use, some of it comes from deforestation, some of it comes from weird stuff like making cement, but most of it comes from simply burning fossil fuels for energy. So, and I'll leave you with that. So we have more carbon dioxide, the Earth is now resetting to a slightly warmer temperature. We're not totally sure what that will be, but just remember that the difference between the Ice Age and one of our interglacial periods in which we are now is about 4 degrees Celsius average temperature. So a very small shift in the average temperature of the Earth can give you a very, very significant shift in what that Earth looks like. So when people are concerned that there's not going to be an Earth after global warming, no, the Earth will still be here. The Earth will be fine. It's just that, Bangladesh might be underwater. So not only are we concerned about ecosystem damage and shifts to natural systems, we're really mostly concerned about what's going to happen with some 8 billion humans who are here. And you can kind of imagine how this is going to go. Those with the least resources are going to be impacted the most. So, but how are our plants going to be impacted? And we can divide this into a few categories. Basically, we can talk about temperature impacts, we can talk about moisture impacts, and that's pretty much where we're going to be today. So when you're looking at temperature impacts, we know that temperature goes up. That means both the minimum winter temperature goes up and the maximum summer temperature goes up. Everybody clear on that? Okay. So the minimum winter temperature is what gives you your USDA hardiness zones, right? We don't care too much about that because we don't have freezing temperatures here much. But there's a couple of things we should talk about. So if we move our minimum winter temperatures up, we're extending our growing season. And by so doing, we will require more water for our plants. That is simply the way things go. Irrespective of how much water we have or don't have, if you can grow plants longer, you're going to require more water. We'll see what happens when that maximum temperature goes up. That has a slightly different effect, but it's going to be the same deal. We're going to need more water. We're also going to extend the pest season, and this has already happened. So in situations where we only had 1 insect generation per year, now we have 2, because insects and many other animals that depend on the outside temperature to regulate their life cycle develop more quickly when it's warm. So if you remove that really low winter temperatures, where you had 1 generation of, say, some of these bark beetles, you now have 2. Okay? For home gardeners, you can expect your aphids to develop a lot more quickly. So have fun with aphids. So the other thing is this idea, okay, we've moved the lowest winter temperature up, we've also moved the highest summer temperature up. So what does that mean? Well, this is the heat zone map, which nobody uses, as far as I know. Yeah. There's always these overachievers who don't jumping up and down. I don't know why this is never caught on, but this basically shows you the number of really hot days. And again, obviously, that goes up as well. And what that means is the water demand goes up through a slightly different mechanism, and that's the vapor pressure deficit increase. Why? It's because it's warmer. And as you increase temperature, what you're also doing is you're increasing the ability of the air to suck water out of the plant. That's called vapor pressure deficit. It's the way we feel humidity, how we feel, it's not that it's humid. Well, plants feel vapor pressure deficit. And it turns out for the same relative humidity as the temperature goes up, that vapor pressure deficit goes up really quickly. That's why people who run greenhouses keep greenhouses really moist, because they know If something goes wrong with their misting system, the place is really warm, those plants are going to wilt real fast. So that tells you that this is something that's been recognized for a long time. Well, if we make our climate warmer during some time of the year, we're going to increase that water demand on plants. So precisely the times when we typically don't have water. Now, when it comes to water, before we look at what's going to happen with water, just a reminder that our water situation in California is extremely variable. So this is a really good map by a dude named Michael Dettinger, who tends to produce really good stuff. And what the color represents is annual coefficient of variation. In other words, when you look from year to year to year, how consistent is your rainfall? So if you're east of Mississippi, the variation is almost zero. Like, you get the same amount of rain this year that you did last year, that you did the year before. Maybe it varies by month, right? But year to year, when you take a whole year, it's about the same. When you look at sort of the Intermountain West, well, there's a bit more variation. And then when you look at California, it just falls apart. We have drought year followed by not so watery, right? Just like this year, right? That's normal for us. This is before we get climate change. We don't, I guess you would say reliable, we don't have a reliable rainfall. This is why we built all those dams, all those gigantic dams and canals, because we're trying to even out this enormous natural variability. This is important to you because if you're talking to somebody who just moved here from New York, they're expecting that. They're expecting the same amount of water. Somebody who moved to Oakland from New York this year is going to be like, well, yeah, December and early January is crazy. Is that what's going to happen next year? I don't know. Probably not, right? If it didn't, who would be surprised if we had a dry January next year? People would be like, oh, this has never happened before. No. You know this, your clients might not. And so this is the sort of arm-waving summary of what's going to happen with rainfall. The models are not consistent. So some of the models basically predict that we're going to have a slight increase in rainfall, some predict a slight decrease. They all tend to agree there's going to be more time in between big storms, and the shoulder season, so the fall and the late spring, are going to get less water. And rainfall is going to become a little more concentrated in that winter heavy rain season. That's what the models agree on. So I would go with that. I would go with that as sort of our message. Even more variability, more time between storms, larger storms, and a kind of compression of the rainy season to the winter months. Not good, really. But again, regardless of what happens to the rainfall, plants are going to need more water because it's warmer. Good. Snow. The models unfortunately do agree that we're just going to have less snow. We're going to have half as much snow 100 years from now than we have today, which actually beats Arizona, because they're going to have practically no snow 100 years from now. I didn't know Arizona had snow. So, kind of, water situation is maybe a little more ambiguous than the heat situation, but it's not good. And then finally, I want to talk about this, because this is an interesting thing that just happened. This is Becky Bollinger from, I think, Colorado State, or University of Colorado, and colleagues. Did you ever wonder when people say, oh, it's an above normal January? What is normal? What does that mean? What the heck does it mean, normal? I mean, I'm clearly abnormal, but, you know, what does it mean that the rainfall was above normal? Well, normal is a long-term average, but it turns out you have to actually do the math. So where do you make the cutoff? Until last year, the period that we're using to determine what is normal, so it's a long-term average, right? You take all the Januaries and you say, okay, the last 20 Januaries, how much rain did we get? Well, we were doing it for the 1981 to the 2010 period. Okay? That was normal. And in fact, I'll show you the website where it says that. Then they changed it. The National Weather Service said, well, you know, we have another 10 years worth of data now. We should adjust that. And what they did is they just moved that window for calculation 1 decade over. So it's 1991 to 2010. That's the average. That's where the average is calculated. Well, some clever people, again, Bollinger and I forget the other author, they asked a very simple question. So are those averages higher than they used to be for the 1981 to 2010, or are they lower than they used to be for 1981 to 2010? What do you think the answer is? And the answer is, it kind of depends. So if you are east of the Mississippi, the colors give you the number of months in that 30-year period that are either above or below. So it turns out pretty much everybody other than a few weirdo counties, I don't even know where that is, but basically everybody is a little bit warmer than they used to be. The normal temperatures are a little bit warmer than they used to be, okay? Whereas in the kind of Southwest and in Florida, they are a lot warmer than they used to be, okay? So we can do the same thing with rainfall, and they did, and this is the average. Now this is fascinating, because again, you can have more rain than you used to have, or less rain than you used to have, and if you are in the east, the green colors, it turns out they have a little bit more rain than they used to have mid-20th century. Again, if you're talking to a client who just moved here from Rhode Island, they did not experience a loss in precipitation. They really didn't. I can show you the data if you have endless patience on the XMASIS website, which we'll look at. But for those of us in the Southwest, we absolutely are getting less rain than we used to get. Okay? So our normal temperatures are higher, our normal rainfall is lower than it used to be. There is a paradoxical effect of this adjustment, and I think some of you are already seeing what's going to be happening. We now have fewer above normal temperature days, and we now have fewer below normal precipitation months. Do you understand why? Okay, right, because we've adjusted the normals. So we expect, so in other words, when you look at your TV meteorologist, she is less likely to say, oh, today is an above normal warm day, because we've adjusted the normals upward.
We changed the rules.
We changed the rules, basically, yeah. That's a very good point. I mean, it sounds like we did something sneaky, but we didn't. We just said, look, if you're 30 years old, right, you lived in this period. I mean, that's the climate you've experienced. In fact, you're 40 years old. God, I'm old. If you're 40 years old, you experienced, most of your life was this new period, not the old period. If you're 30 years old, you've only experienced the new period. So keep that in mind. So now what? Well, what this means is that some of our trees are not going to do well. Beautiful example from the beautiful city of Oakland. And what we would really like to have is something like this. This was a study they did for the Central Valley. Crops, these are crop yields. The two lines indicate two climate projections. You can go with a less warming projection or a more warming projection. You can see that if you're growing cotton, well, things are not going to look so great. If you're growing alfalfa, yeah, everything's cool, right? This is you're going from year 2000 to year 2100. Wouldn't it be great if we had this for tree species? Like that? Yeah, big cool. Nah, it's made up. We don't have that. So we need to try to think about how we could approximate this. And one way to approximate it is to substitute space for time. Which is basically this. Is there a city today that has the climate that's predicted for Alameda? I'll use Alameda because we're in Alameda. That's predicted for Alameda for 100 years from today. And then do the trees I care about live in that other city? That's it. That's the whole substitution of space for time. Okay? Instead of waiting 100 years to see whether those trees are going to do well, we're going to go to a place that today has the same climate that's predicted for us in 2100. Okay? So here's an example. City of Eureka, all the way up north, is predicted to get roughly the same summer temperatures that Berkeley has today. So the high in July in Berkeley is 70 degrees, the high in Eureka is 62, but Eureka is predicted to reach the July maximum temperature of 70 degrees. So what you can do is you can look at the trees that grow in Eureka, species A, B, C, D, then go to Berkeley and say, can we find species A, B, C, and D? And if the answer is yes, those are probably okay to keep growing in Eureka. Okay? In contrast, and I am tipping my hand here, I am giving you kind of the preview of the results. You go to Fresno, currently at 95, in July, predicted to go to 108. Is there a city in California that gets to 108 in July today? Well, yeah, barely. El Centro. Same deal. Look at the species in Fresno. Go to El Centro. Can you find those same species? No. We're missing some of them. And so when we did this, and we did do the study, Professor Joe McBride, who's Berkeley, and I, this is some of the cities we visited, and we basically use the same city twice. We used it once as its own thing, and then again as a reference, the warm city. So for example, for Berkeley, I already told you Eureka is predicted to reach summer temperatures that Berkeley has today. What about Berkeley? Berkeley is predicted to reach roughly the temperatures that Santa Ana has today. So when we did this, and I'll show you you don't have to worry about or did I? No, that's right, Santa Ana. When you do this, here's the results. And I know you're not terribly interested in sort of mega scale results, but basically the coastal cities tend to do well. The inland cities tend to have a bunch of trees that we don't find in that warmer equivalent. So, which is kind of interesting. I mean, part of it has to do with the actual predicted increase in temperatures. Part of it just has to do with the species they chose. The coastal cities seem to have lucked out a little bit. I don't want to say coastal cities made all the right choices. They kind of lucked out. What's interesting about this is we tried to then square this up with expert guidance. We looked at books, basically. And it was kind of interesting when you ask the question about should this tree grow in this city? Right? That's the question we asked of a couple of really famous books. There's three possible answers. The expert could say, no, it shouldn't, and then that would match up with what we found. Or the expert would say, well, you might have found it, but it shouldn't grow there. It's too hot. You might have found it, it's a fluke. Or the expert would say exactly what we found. So they could be sort of optimistic, they could be pessimistic, or they could be kind of neutral. What was fascinating is that in every single case, the books predicted that trees should grow in places where we didn't find them. So books were much more optimistic. Now, this study only dealt with street trees, and you can immediately start to think about, well, yeah, of course, I mean, how much care do street trees get? But I think there is a lesson here for home gardeners. What you expect people to do, and what those books expect people to do, people often don't do. Right? And so trees fail. So again, when we're talking about tree species selection, think about that a little bit and say, is this a tree that needs extra care? Is this person likely to give them extra care? And if you're looking at lists, this is something to really kind of consider. You will find trees on those lists that are really exotic. They're something that's not grown much, that's being trialed somewhere at some university, and that you can order through a tree broker from Arizona for several $100s. Should you recommend that to your client, whose spouse forced him to come to your help desk, who otherwise has no interest in gardening? Should you suggest that he spend several $100s ordering a special acacia tree from Arizona? I would suggest no. You will estimate the future average maximum temperatures, and we'll try that in a second using Climate Explorer. There are multiple tools you can use. I think Climate Explorer is the easiest. And then, or you can use some of these published things. This is fun, right? San Francisco is predicted to get to the same climate that Rancho Palos Verdes has, which is really fun, because Rancho Palos Verdes is like the richest place in LA, and of course they picked that. It's just like Rancho Palos Verdes. Whereas Phoenix is predicted to get to something like Kuwait city level heat, so good luck to them. But that's your second step, and then your third step is to actually contact somebody and talk to them. And you do want, one thing we learned from our studies, you want to repeat this with at least one other person or one other warmer city. Sometimes trees are missing from a city simply because nobody tried them out, nobody planted them. They would grow there, it's just that specific tree nobody's tried. So the only way to get around that is to then find another city that's as warm or warmer and give them a call as well. And if they say, oh yeah, we have those, no problem, then you can say, okay, I feel reasonably confident that the first city they never tried these trees. So what can you get from Climate Explorer. This is the Climate Explorer graph, and again, we'll try this in a second. It's for Hayward. But what you're going to do is you're going to you're going to say Hayward or whatever city you want, and then you're going to say monthly average daily maximums. I think it makes sense to use that because it's something that's readily available. And then you're going to select the time period, and this is somewhat important. There's time periods at the bottom. I think you want to go as far out as you can, which is 2099. It's 2100 basically. And then you get a graph like this. And what these lines indicate, they're kind of the averages and the confidence intervals, but they give you an idea, and you just move your cursor and it'll actually give you the number. Okay? You write that number down. Then you go to your friendly map of California, and you look for some cities. And then you can either use the NOAA's weather data, which are actually kind of hard to use, or you can cheat and just use Wikipedia. Type in like Santa Ana, and it'll give you that climate graph, and you'll get the warmest month. And you do this a few times until you find something that roughly matches. So the thing is, you don't have to match this exactly, and you won't be able to because there isn't an endless number of cities in California, right? So we went to El Centro because it's a reasonably large city. There are other cities in Imperial County, but they're tiny, right? You want to talk to somebody who's in an actual city, right? So this will take you 10 minutes to figure out, right? Rancho Palos Verdes probably wouldn't be my choice. I would just call somebody in Long Beach, right? But in Rancho Palos Verdes. But you also have this other option. If you really hate people and don't want to talk to anybody, UFI, Urban Forest Ecosystem Institute at Cal Poly San Luis Obispo, has a bunch of stuff that you should be familiar with. And the two things that I think are really relevant for this little exercise are select tree, and I presume at least some of you have used select tree, right? If you want to learn about a tree species, about its characteristics and growing needs, select tree is your friend. There's also an urban tree key if you are trying to identify something. So there's at least 3 things on UFI that you should be familiar with. But they also have this thing called the Urban Tree Inventory. And what they did is they loaded up a whole bunch of tree inventories from California. There's, I don't know how many millions of trees loaded in here. And what you can do is once you've found that equivalent city, say Santa Ana for Berkeley, you might not even have to talk to anybody in Santa Ana. What you do is you go to this inventory, you put in Santa Ana, the thing pops up, and it actually gives you the most common trees right there. You don't even have to query the data, it just pops it out for you. Now, if you know a specific tree you're looking for, what you would do is you would then put it into the search box. And it would either say, yep, we have 72 of these growing in Santa Ana, or it would say, no, we don't have any of them. And so if it says we have 72 of these growing, you can probably stop there. And you can say, yes, the camphor tree, which everybody wants to grow, grows well in Santa Ana. Now, if you get a no, if it says this doesn't grow in Santa Ana, then you might have to call. Then you might want to call and say, hey, is that really right? Is it really true that you don't have any bunya pines in Santa Ana? My favorite. But do you understand how you would use this? So you use the Climate Explorer to find your predicted climate. Then you use Wikipedia, really anything, to find a city that has that month matching today, right? It's going to be Southern California, right? You're not looking at Oregon here, just to be clear, right? Southern California. Then try out the urban tree inventory. Say, okay, it says, I don't know, it says Huntington Beach. Let me see if Huntington Beach data is in here. Oh yeah, look. And if it says, here's the 5 trees I'm concerned with, yep, they all grow in Huntington Beach, you can probably stop. If the inventory doesn't exist, and for a lot of cities it's not uploaded, it exists, but it isn't uploaded, or if it says, no, the bunya pine doesn't grow in Huntington Beach, okay, now you need to make a phone call. What else can you do? Well, you can certainly talk about the natural range of your trees, especially for native trees. So this is from CalFlora, and I'm sure a lot of you know and use CalFlora, but it gives you ranges for native trees. And this is occasionally very useful when you're talking to clients who are just not getting it. And for example, they want to plant redwoods everywhere. So this is the current range of the coast redwood. As temperatures warm, what will happen with that range? It's going to move which way?
North.
Up, that's right. So if you're at the down end of the range, as the range moves up, the range will leave you and you will no longer be in the range of coast redwood. In fact, most of our cities are already not in the range of coast redwood because it's warmer. We'll talk about that in a second. Whereas if you're looking at something like coast live oak, which by the way is the most common urban oak in California, half of all the oak trees in that urban tree inventory are coast live oak. Coast live oak range extends all the way down to border of Mexico, basically, into Mexico. So if that range moves up, well, we're still going to be within, right? This can be useful, but again, this only exists for native trees. And even for native trees, we'll get to the thing in a second, you have to think about your site. So we talked about that, so let's talk about the site, because this, I think, is something that we're skipping, and we shouldn't be skipping. You really have to think about what your site looks like, because you're not planting a tree in Oakland or in somewhere. You're planting a tree right here, in a very specific place that may or may not be suited for that tree, or the tree may not be suited for. I like to think of everything from a tree's perspective. So, right, you're planting a tree in a parking lot. You're planting a tree next to the southern facade of a house or next to a northern facade of a house. It matters. And again, your clients, a lot of them, this is not something they're thinking about. But you will help them think about it, because this then kind of will guide you. Well, do you really want to plant a redwood here? Well, yeah, they grow in my neighborhood. They grow in your neighborhood, but you have a freaking patio that's all cement, and you cut out a 3 by 3 foot hole. Are you sure about this? And they're like, yeah, of course I'm sure. Well, let's talk about that. And I don't know which site assessment system you use. This is a Cornell one. I think it's a decent one. I think the Master Gardener program has a site checklist somewhere. But I'm happy to revise this. I am working on revising the Cornell one because I think it's pretty good. But what you're going to do, and this is, you do this for anything, but certainly for a tree, that's a 100-year decision, right? You certainly should ask yourself, what's your hardness zone? What's your sunset garden zone, right? Different things, because the USDA zones are not that super useful for us. And then these microclimate factors are really what you want to focus on. Is there reflected heat? Is it in a giant patio? Is it on north side? Is it on south side? Is it exposed to wind? All of these things matter. And it's useful to have a checklist like this that you can give to the client, be like, let's check this off together. So that then when we go to select tree, because we're going to select tree in a second, right? Because you told me you want fruit, but you don't want any mess, and you want birds, and you want the tree to be very tall, but also very small. We'll go to select tree, and we're going to put all your wonderful requirements in, but we're going to have this to then check against what the select tree tells us that tree needs. Okay? So some kind of a site assessment. What's your sunlight? What's your irrigation? Right? And again, we're not going to go through the entire Cornell form, but this is the way, I think, to think about what does your site look like. Right? We can't skip that part and just go to climate change. Climate change. Gotta plant some mesquite. Gotta plant some mesquite. Well, hold on. Let's look at the site first. Mesquite may be appropriate, usually not, but let's look at the site. If it's, for example, waterlogged clay, because you happen to be at the bottom of the hill, yes, mesquite is not going to do so well. And again, what would we consider here? How many of you have recycled water available in your neighborhoods? Nobody, huh? Yeah, freaking fantastic. We've wasted like 30 years of not putting that in, so good luck to us. How many of you have gray water, or have any interest in gray water? Okay, at least a few people, right? So that's something, right? Even if you don't use gray water to irrigate the tree, you can use it to irrigate the rest of your yard and save the potable water for the tree. Stuff like that. Do you have mulch? Do you want to put mulch? Do you hate mulch? Okay, something to understand. Do you have turf? Do you want turf? Do you have artificial turf? Again, things that maybe Cornell's not going to ask about, but we should probably ask about. And so one tool that I would suggest you try when we're talking about this is the XMASIS, which has to be the worst named government thing ever. Because I remember when the dude in Monterey told me about it from Water Service, I was like, what? Anyway, that's what happens when you have too many people with PhDs in the same room. Again, I'll send you the link. That's a National Weather Service tool for retrieving weather data. And despite its horrendous name, it's really easy to use. All you do is you select what you want, and you select the location, and you select the dates. It's 3 things. Real easy. I can show you in a second if you want. But one thing it will do this accumulation graph, which means it's a giant bucket, and you're filling with rainfall. And there's a line that shows you how much rainfall you should have had based on the what now? 91 to 2020 normals. That's right. That's this little orange line. And it's smooth, right? Because you average the data from 30 years, so the line is smooth. It's like you get a little bit of rain every day. Oh, by the way, until you get to the summer where you don't get any rain. Important for your clients who just moved here from Vermont or Louisiana. Right? What is this? Why is this line flat in the summer? Right, it's accumulating rain and then it stops because there's no rain to accumulate in May, June, July, August, September, and then it restarts, right? Very important. This is not what it looks like in Vermont, by the way, at all. In Vermont, the line just goes up through the year because they get precipitation year round. This is very important. Anyway, the green is the actual. So this is, oh god, it's all blurry. This is 2022, I think. And you can set the date range however you want. And what's interesting, if you want to mess with this, if you set the date range to be about 20 years, so from about 2002 or so, the 2 lines are kind of on top of each other for a long time. And then around 2013, that green line kind of falls down a little bit. And it just ever so slightly starts falling. And you're like, wait, what's going on? That was the drought. And we've never caught up, by the way. Okay? So it's kind of an interesting exercise. Then you repeat that for Atlanta, for New York, for Chicago, and you don't see that. The 2 lines stay together. So the West really does have less precipitation than we ought to have. You can do the same for temperature. This is for 2020. I like the blue is the actuals, the red is the record heat, the blue is the record cold. And does anybody remember 2020? It was a fun year. Do you remember what the winter looked like? When it was ridiculously warm? All of a sudden, that's when your blue line hits the top of the red. You see that? That's when you were breaking records. This is very useful. When a client comes in like, my price hydrangeas look terrible. Well, did you water them? No. You can do, again, XMA is the same deal. Instead of saying accumulation graph, what do you say you want? It's not rocket science, temperature graph, right? So, okay. So basically that's it. We talked about how to think about it. We talked about the process. We talked about some of the tools. This is kind of the summary, right? You do want to know what your tree's environment is and what its own climate envelope is. This is really tricky, but the basic idea is, are you at the edge now, right? Are you a sequoia or are you a coast live oak? You do want to consider pests, because we're going to have more of them, and you definitely want to consider your tree's water needs. And we can always have that talk. We had that talk in Concord a few years ago. We can have it here about how to calculate water for a mature tree and how to apply it. But that's basically it. If you want, I'm happy to take questions, or I'm happy to show you those websites and tools. What do you want? Or we can be done, because we're past time.
Could you do the information? What you would do?
Yeah. So we said we would have a talk about how to talk to home gardeners about tree risk and how to hire an arborist. So we can do that. I probably need about a month to put that together. So somebody is going to call me or email me and say, you promised. And I'll say, oh, I don't remember that. And then we'll do that. And I think the interest was in, we had a bunch of storms, we had a bunch of tree failures. And then we had, I'll give the arborists on TV arborists, I'll give them some credit, because what they said for the most part was, don't rush out to remove all your trees, which is, counterintuitive, because they charge you to remove your trees. So but at least they got the message, which was when you have these really unusual events, it's not a good benchmark for how your trees are going to perform. So don't oh, the tree didn't withstand a historic storm. All the trees need to go. Which, by the way, is exactly what happened in my neighborhood. One tree fell over. I couldn't even hear it. I heard a crack, and I was like, that sounds like a tree falling over. But it was dark, and it was raining, and I don't like to go outside when it's dark or raining or sun. And it did moderate damage, so probably a couple $1 million, right? Nobody got hurt as far as I could tell. They immediately removed the adjacent tree. And I'll show you the picture in the presentation because one of those trees looked really terrible. That one fell over. The other one looked fine. So that's probably not what we want to encourage our clients to do. So how do we talk to them about tree risk? How do we help them hire an arborist so they understand what it is they're paying for and what it is they're getting, which I think is important. I had somebody yell at me on the phone that they hired an arborist. That person didn't do anything. Oh, okay, you hired this person to evaluate your tree? Yes! How much did you pay them? Oh, I didn't pay them. Okay, then you didn't. Do you know what I mean? Okay, let's talk about what it means to hire an arborist to evaluate your tree. So this is all important, right? Because it's very clear that people are not, that there's confusion. And I understand why people are reluctant to trust the information put out by the arboriculture industry, because it's expensive. So let's talk about how much things cost and maybe the best way to steer clients. Okay, so we can talk about that in a month. Thank you. You'll remind me or somebody will remind me.
Yes.
Okay, yeah.
Yes.
Can you say something about what you folks are doing with the tree growers who are supplying the nurseries in terms of educating them and what they're producing and making available to the public, which in a way is part of the problem.
Right. So the question is, how do you change what the nurseries are producing? And it's a chicken and egg problem. Nurseries will produce whatever the heck they can sell. And I will tell you, I made a little bit of a mistake. The San Mateo program wanted me to do a tree planting thing for them. I said, yeah, great. Let's get a island oak, a beautiful tree. I didn't realize those trees are not readily available. So this tree ended up being brokered from somewhere. I'm afraid to ask the master gardener how much he paid for it. I know those are being produced wholesale. They're just not available retail. So there is a shift, and the nurseries. The wholesale nurseries have begun shifting their palette toward things that are more drought tolerant, mostly because their commercial and municipal clients are demanding it. So few commercial and municipal clients are planting sequoias at this point, right? They want oaks, and they want, for example, Mexican oaks or some Southern California oaks. They want elms, but they want elms that are hybrid elms specifically tolerant of low water, or hybrid maples, again, something that has genetics that's tolerant to low water. It'll take time to shift the retail nursery, and I think the best way to do that is to shift kind of the information we're providing. And it's a balancing act, because again, I just screwed up, right? I say, island oak, great tree, from the Channel Islands, it's pretty, let's try it. The thing was like that tall. I was like, how many hundreds of dollars did you? I don't know. So, whereas I know a wholesale nursery that has it about 50 miles away from here. So it's going to be a process. But I think what you can do for home gardeners is really steer them away from things that are high water use. That are always going to be available, by the way, because somebody likes it. It's like houseplants, right? If you go to a houseplant section, you got your crotons next to your sansevierias, next to your cast iron plants. You're like, these are totally different light. They meant no. Hipster couple with a giant shopping cart, don't put those three things into shopping, because no, they're not going to grow together. They're going to die. Croton's going to be dead in like 2 months. Should they stop carrying crotons? Well, probably. But, you all could probably grow those plants just fine. So again, it's that thing, can you shift what people are buying? I think the answer from your side is yeah, you can.
Thank you.
There's a question here, Joan?
So the timing, so you're recommending these trees that now grow in Santa Ana to be in
Yeah.
Berkeley, but the tree that grows in Santa Ana today wouldn't necessarily grow in Berkeley today. So
Yeah.
is there a timing of?
This is an excellent question. Actually, I like not having questions like that. So that's an excellent question. Because Santa Ana is probably looking to plant trees that will grow in Santa Ana in 100 years from now. They probably are planting mesquite. And you're right, we probably shouldn't. So that's where you go back to select tree and say, okay, what are this tree's actual needs? We have an advantage in that we don't have really cold winter temperatures. In our study, we actually ran into that for a couple of cities. Turned out not to matter, but some of the cities that have really hot summers also have really cold winters. So here, that's not going to be a major factor. But you are right. If you are really looking at trees that grow in completely different habitats from what we have, then it's really important to go through that site checklist and say, do you have access to water? If you do, don't grow desert trees. Like it's just not going to work. They're just going to die. The flip side is trees are very, very adaptable. Trees are shockingly adaptable. My street is covered in liquid amber. If you ask me whether a tree from the southern US would grow well here, I would have said no, probably not. Liquid ambers grow like crazy. Magnolias grow way too well.
Yeah.
And then, of course, the ultimate are fan palms. I know you're not going to recommend fan palms, or you're not going to tell people, but look at them, it's nuts. San Francisco, the horrible nightmare of a sidewalk nothingness around the Levi Stadium, they've got all those tall palms. And you go to Joshua Tree or to Death Valley or to any place that has oases, right, where you can see how California fan palms actually grow. And it's like, okay, there's similarities. There's a lot of heat, not that much water, not very much soil. There's similarities. It's just the climate's totally different, right? So plants are very adaptable. That's what complicates things. But a good question, and one that you have to. That's the story time, which is what I'm doing, versus what you're going to be doing, which is guiding an individual client to an individual tree at an individual site. Much harder than what I do.
Ed, did you have a question?
I do. It's a great thing. The thing I really don't understand is why do we go to 2100? The trees, the average urban tree is like what, 10 years old?
No. Nope. That was a terrible pseudo study it wasn't a study. Somebody asked a question from a bunch of people, hey, how long do urban trees live? And somebody said 7 years. And they're like, 7 years. No, but you're not too far off, unfortunately.
They're not 100 years old. They're not.
But I want them to be 100 years old. Well, hold on. This is a very important point. So let me take it one step at a time. Urban trees' half-life, so the point in time where half of them have died, is probably around 30 years, right? So they do live longer than that story time, and this is actual studies by one of my very smart lab mates, Dr. Laura Roman, who's with the Forest Service. And she actually went out and measured stuff. And so there's a range, and that's a fascinating story. But here's the thing. When you look at tree benefits, so ecosystem services, human health benefits, and wildlife and ecological habitat benefits, all of those really start to accrue fairly heavily. And you know that, right? As trees age. So we're trying to get trees to live longer. Now, a big part of that for home gardeners is the stalk quality. When you pull that thing out of a pot, you wash the water off the roots. If it looks like a giant corkscrew, then it's going back, either to Home Depot or nursery or wherever, right? If it actually has a good root system, okay, now we have the first ingredient we need for success. If you then have a reasonably good match between the tree, the site, and the availability of water, you can grow those trees to 100 years old. And we can go around. Okay, Alameda might be a bad example, but we could go around and find trees in Oakland that are in Berkeley that are 100 years old. So it's definitely doable, and I would like people to try. Now, you can go to Climate Explorer. I'm not going to do it because we're way over time. But you can go to Climate Explorer and just select which one you want. You'll see that in some cases the difference isn't that great. So, what difference in what? The difference in maximum July average temperature. So if you want, you can say, I want to go to 2050, and then use that. You'll see it's not that different.
Okay, so it really doesn't make much of a difference is what you're saying.
It doesn't make a gigantic difference. It does make a difference, and for some cities it'll make more difference than others, and depending on which emission scenario you use, it'll make more difference than others. So if we do something, we all know we won't, but if we do something about carbon emissions, then the difference between 2050 and 2019 shrinks. If we don't do anything about the climate emissions, then that stays.
And these are like the 1.5 to 2 C.
Yeah, you're looking at something like, in fact, that difference is going to be probably about 1 degree Celsius, 2050 to 2019.
You know, I was saying the projections that you were using are.
Yes, the projections, yeah, a couple of degrees Celsius warming, yeah. But that average. So for maximum summer, that's like 4, 5, 6, 8 degrees, right? So the maximum, the average maximum temperatures increase more than the average temperatures. Just kind of keep that in mind. So the hottest days are going to get a lot hotter when you compare them to the average change. So just kind of keep that in mind.
No, what I was trying to say by that is that's kind of the lower end climate change projection that we think might happen, but there's, I mean, it could get.
Oh, yeah. No, we're using like consensus middle of the road projections. Yeah, absolutely. Yeah, you can blow everything out of the water if you want, but no, we're using like middle of the road emission scenarios and what we're talking about is something called climate sensitivity, and this is one of the things people actually argue over. If you increase the concentration of greenhouse gases, how much does that increase the temperature? That's something people are arguing over. But again, we're using a kind of middle of the road projection. Yeah, way in the back.
Yes. Going back to what was just said a minute ago about the fact that a tree planted in Berkeley now, recommended from Santa Ana temperatures, would it make sense then to sort of look halfway between Santa Ana and Berkeley to find a tree that would do well there and plant that? Sort of hedging your bets there, going halfway?
So, good question. I wouldn't, as long as I were reasonably sure that the tree in Santa Ana will survive the conditions in Berkeley today. No, I wouldn't. I'm a pessimist. I don't think we're going to do anything about global warming. I think, the scenarios we're looking at now, the middle of the road scenarios are actually going to turn out to be optimistic. Yeah, I think things are going to get worse. No, I would, because again, I really want us all to think in 100-year terms. Maybe that's unrealistic for, say, street trees. And I think there is an argument to be made here, which is, before that tree dies, there's probably some moment where it becomes really expensive to maintain, and that balance of cost benefits shifts. But you're not dealing with that. You're dealing with home gardeners. For home gardeners, I want spectacular big trees, or spectacular small trees, if that's their choice. That's their choice. But I want spectacular 100-year-old trees. You can do it. You can do a buckeye. You can do a little, what do you call it? There's a number of trees that will do 100 years and stay small. There's a number of oaks. But I want 100 years. I want cavities, I want bees, I want birds, I want all kinds of nonsense 100 years from now. Right? Yeah.
Do your studies also include looking at ocean rise in flooded areas like Alameda maybe?
They do. We actually had a slide on that and I took it out because we have too many slides. Yeah, let's not talk about that, because it's a whole nother discussion. But basically, if that is something you need to worry about, there's not a great way around it.
I mean, in terms of having a list of trees that we're going to take better more inundation, so like say, trees that grow out in the valley and close to riparian areas.
But you are talking about inundation with to be a real short list of species.
Right. Mangroves?
Mangroves good.
Yeah, I'd rather focus on the site and saying, can we figure something out at the site that's going to keep us out of that saltwater intrusion zone. Good question though. I don't think anyone's really done work on that, to be quite honest. Maybe somebody in Hawaii, but not here. Like half of Honolulu is gonna be underwater. So that's why I'm thinking maybe Hawaii. Okay, I've gone way over time. Thank you all. I will send Joan the link so you'll have that. And you know what we can do is we can actually record a 10-minute video on what to click on each of those websites. I think you can figure it out, but Joan can tell me if that'd be useful, and I can just record myself clicking stuff.
Yes.
Very useful.
Yes, do that.
Okay, we can do that.
Absolutely.
Thank you all, and
Thank
thank you, Irene, for bringing the cable. So.